dari grup 8. Kami punya title Automated Irrigation System Supported by Soil Moisture Sensor. Kami punya 5 member, saya, THEDORA, ini NADHRAH, FEDRICK, Qystina sama BELA. Oke, seperti yang kita tahu, kita nih banyak masalah air di sini. Jadi kami punya grup nih mau mengurangkan pembaziran air. Lagi-lagi di kalangan pekebun. So pekebun kan dia banyak guna air di tanaman dorang. Jadi kami mau kurang pembaziran tu lah dengan kami mau memudahkan dorang. Contoh macam musim kemarau kan, dorang susah mau pergi melancong ataupun pergi tempat lain yang jauh-jauh lah sebab dorang terpikir dorang punya tanaman di rumah tu tidak dapat siram kan sendiri. Jadi kami ini project fokus on developing an automated irrigation system that utilize soil moisture sensors to optimize water usage and enhance crop productivity. Ini kah? Next, objektif kami punya grup ni, kami punya project first to design and implement cost effective and efficient system for irrigation. Second, to leverage soil moisture sensors for delivering water directly to plants based on their specific needs. Next, to minimize water waste by irrigating only when necessary. Next, to maximize crop health and productivity. Last but not least, to promote sustainable agricultural practices adaptable to various farming scales.
Next, saya tentang comparison between manual dengan automated water irrigation. Seperti yang kita tahu, for manual, dia usually efficiency dia low sebab dia terlampau tak dikawal. Tapi kalau untuk automated, dia tinggi, efficiency dia tinggi sebab kita kawal benda tu. And then water usage dia untuk manual, usually dia punya water dia terlampau banyak keluar ataupun dia terlampau sikit keluar. So benda tu usually dia jadi wasteful. Kalau untuk automated water dia kita boleh optimize dia. So tak ada pembaziran lah di situ. Kalau untuk masa time required untuk manual, usually dia perlu banyak orang. Usually use for time required, the manual water irrigation usually dia labor intensive. Lepas tu kalau if automated, they usually save time with automation. Maksudnya untuk cost, then like usually it's much more cheaper and then costly for long term. Kalau for automated water management pula dia higher upfront, maksudnya it's more expensive but it saves in the long run. For crop health, usually manual water irrigation, there risk of underwatering or overwatering. For automated, it maintains the ideal moisture levels. Meanwhile, for environmental impact, the water runoff is more and less sustainable. Meanwhile, for automated water irrigation, it is environmentally friendly. For manual, it requires manual work. Meanwhile, for automated water irrigation, it needs minimal effort with remote control.
Okay, so for now I will share with you the material selection for our group. So there are only several components that we need. And one way is soil moisture sensor. Soil moisture sensor is, they have two probe. The two probe will be inserted in our soil like this. Okay. So the higher the resistivity, the drier the soil. Okay. So now we have Arduino Uno 3, which is located inside of our, I don't know what's box inside of this. So this Arduino are the brains of our project lah, because it will control the data given by our software, and from our sensor it will connect with the software, and then will connect the relay module to let the water flow. And now we have lithium-ion battery. Lithium-ion battery is needed for our power supply. We use 6 volt for our water pump. It's need because our water pump is basically, our water pump need like 5 volt of power lah to operate. And now we have single pole double throw switch. Basically, it's used as a switch lah for our project, but automatically it will the information that was given by our coding, and the switch will just like, you know, having the data given, and it will turn on and off lah our component. And finally we have water pump. Water pump, like I was tell you earlier, it works as at 5 volt. So the power supply will give power to water pump, and then the water pump will turn on if the resistance is high because it's dry, and vice versa. Thank you.
So now I'm going to present on how it works. So for the automated irrigation system, it utilizes soil moisture sensor to monitor soil condition and to ensure optimal watering for plants. So there are 3 key components. The first one is soil moisture sensor. As you can see this figure, soil moisture sensor, and we have our microcontroller, which is the Arduino, and our water pump. So the key components, the soil moisture sensor detects the moisture level in the soil. For the microcontroller, it processes sensor data and control the irrigation system. So the water pump, it will automatically activate or deactivate based on sensor input. So for the working process, step 1, the soil moisture sensor, this one, it will continuously measure the moisture level. And step 2, when the soil dryness exceeds the preset threshold, the sensor will send a signal to our microcontroller, the Arduino. And then the step 3, the Arduino will activate the water pump to open irrigation valve. And then step 4, once the desired moisture level is reached, the system will shut off the water supply to prevent overwatering. Next, we will show a quick demonstration.
The first one, it will be the using soil moisture sensor will cause the efficient water usage, which delivers the precise amount based on the soil needs. Just now, as we see, and then it also reduces the water wastage and optimize the irrigation schedules. And then the next one is to improve the crop health. It maintains the ideal soil moisture level and promoting health plant growth. It is to prevent the plant for overwatering, which can lead to root rot and plant disease. Next, using soil moisture sensor, it is saving because it reduces the water and energy bills by avoiding unnecessary irrigation. And then it also minimizes the labor cost by automating watering process. And then the next one is the real-time monitoring. It provides the immediate data on real time based on the soil moisture levels. It also allows remote access and control through IoT integration.
Okay, so the automated irrigation system is designed for several key groups, such as farmers and agricultural sector. It helps farmers use water more efficiently and support precision farming for better crop management. Next, environmental researchers. It helps them by so that they can study the water cycle, climate changes, and then predict events like floods and droughts. For policymakers and government agencies, governments can create better water management plans and encourage the use of smart farming technologies. Last but not least, technology developer. They innovate and improve the system by creating efficient sensors and integrating AI and internet for smarter solutions. In conclusion, the automated irrigation system makes agriculture more efficient and sustainable by improving water use and efficiency and reduce wastage, and adapted effectively to diverse environmental conditions, like when there's like drought suddenly, then there's too much water, so like they reduce the water use to water the plant. For the key outcomes, the automation combined with manual control offers flexible solutions and increased crops yield and sustainability in agriculture. However, there are challenges like calibration for various soil types and crops needed, performance evaluation under diverse climatic conditions, and scaling and integrating additional environmental sensor when there's like a sudden change in environment. So like that's all from us. Do you have any question?
What if the water is polluted?
Polluted?
Yeah.
Or we use like we have our own water supply to use for this specific system. Like we don't just use like some random water from somewhere you don't know where.
What if kalau macam yang but what if the water supply is polluted with from animal
Arduino system so that we can see like the graph that shows the reading when the water is being what? Being supplied. So that we can see like if you use like a very big plantation, you have like control system where you can see like the water is supplied to where and when. That's why the graph, our graph was like apa? No, what against what? That's why the graph is water content against time. So yeah, that's how we detect for any like abnormalities in our sensor. But like it's quite hard for, like I said just now, like the challenges we experience here is to calibrate for various soil type and scaling and integrating for like the many sensor we use for like a big plantation. Like